He's the man, he's the myth, he's the legend, he's the scientist with all the answers to all the questions. It's time for another episode of Alex's Science Corner.
Oh, thank you. No, please. The studio audience has doubled for today.
And you're going to be walking a tightrope.
I'm just going to push through. I'm just going to sit back. All right.
I don't believe that. What's going on in the wide world of science, my friend?
Good to see you again, Darnell. So, first story is astronomers working with the Atacama Large Millimeter Array, which is a telescope in the Atacama Desert in Chile, have found more information about the black hole around the center of, or at the center of our galaxy. Now, this is a small supermassive black hole. It's only about 4 million times the size of our sun. And it's also very close. It's only 26,000 light years away. So compared to other black holes, it's nice and close, so we can get more information, but still tough. For many years, they've been seeing a disk of material. We've watched stars do orbits around this black hole. We've seen hot material going around the black hole. But very recently, astronomers have found a disk of cool gas that's orbiting this black hole. And it's more information that we're learning. Now, to put it into perspective, the hot gases they've been measuring are about 18 million degrees Fahrenheit. The cool gases are only about 18,000 degrees Fahrenheit. So compared to the 18 million, they're very, very cool. Still, we wouldn't want to be outside in them.
And the way they know how hot they are, is it the color that they're seeing?
Yes. And when we're talking about...
Because this far away, how do they determine temperature?
It's color. And when we're talking about color, we're talking about the radio frequency it is. Because light, when we look at it, that's radio waves. And so different frequencies of radio waves are different colors. So as things go hotter, they go from radio waves to high frequency to ultra high frequency, eventually into ultraviolet and color. And above that, it goes to X-rays and gamma rays when it goes above the visible spectrum. By looking at the radio signal that these things are putting out, they can determine what its color is and how cold it or how hot it is. And that's how they know.
What's the significance of this whole... Because I read the article, and apparently the black hole that's in our galaxy, right?
Mm-hmm. Yep.
Is apparently, I guess, not as visible as others that they've observed.
Well, yeah. If you remember from a few weeks ago when they announced they imaged a black hole,
right?
That was a black hole that was 6.5 billion times in mass. That was in a completely different galaxy. But because that was so much brighter than our black hole in our galaxy, they got a better picture of that than the one they've got of ours. We can see a whole bunch of other things other than imaging the black hole. So, for example, like I said, we're seeing stars orbit around the black hole. We're seeing different types of gases. We're seeing the different structures of the material that's orbiting around the black hole.
The conclusion I came to, which may or may not be correct, it seems like these things are highly destructive, and that anything near them...
They will start to fall apart. There's an immense amount of radiation because of all this heat, because of all the radiation from there. One of the ways they know that this is cool gas is because the radiation is causing the hydrogen atoms to toss off its electrons. And then all these electrons flying around there are connecting up to another hydrogen atom, and then that electron gets tossed off of that hydrogen atom, and it's constantly happening. And that's producing part of the radio waves that they've detected. And again, what they're doing here is they're finding more bits of this structure. You know, it's like looking at a blob in a picture and starting to get it more and more into focus.
And they've never seen this kind of stuff before. So that's the significance. Okay.
Correct.
All right.
It's more detail that they're finding
that they've ever seen before.
And just real quick, I know Stephen Hawking did a lot of study on on black holes, and so is any of his research coming into play? Is it being confirmed?
Not
with,
specifically.
with this stuff now.
His stuff is more theoretical about the edges of the black hole.
Okay.
A lot of the stuff he was doing was what's happening at the very fine edge of the event horizon and how material and particles around that interact with the black hole and its horizon.
Okay.
This
So
is
this
farther
isn't-
out.
okay,
Right.
okay.
Right. This is farther out. They're just finding, there's one of those things I'm sure astronomers suspected, but until we actually saw it, we couldn't say for sure. Now we've seen this for sure.
Okay.
All right. So next story we're talking about. I know I talked about this several weeks ago, but just as a reminder, the InSight lander, a Mars lander that they landed on Mars. Good, I know. One of the things, it had weather station on it. It had a bunch of other tools. It has a seismic sensor. But one of the things that was really stand out for the InSight lander is it was going to be putting a probe about 5 meters down into Mars.
Now that seems to me super fascinating to see what's down there.
Yeah, well, I mean, one of the reasons was it was a temperature probe, and the idea being by measuring the temperature differences between the surface and 5 meters down, they can learn a lot about what's going on in the core of the planet.
Can you convert meters for me?
Meters is about 3 feet per meter, approximately, so it's about 15 feet.
Okay.
Now, unfortunately, the probe got stuck. When they were trying to get it down into Mars, and something happened, and it only got about 1 meter, so it's not deep enough for them to take good measurements with it. So right now what they're trying to do, and it's going to take a couple weeks to see if these current plans work, they're going to see if they can try to either compress the ground around the probe to see if they can push the probe back into alignment, or if they have to try and lift the assembly back up again to see if they can get the probe out and restart it. They don't know if that's possible, but one of the big experiments that this was sent for is now working, and they know that the probe somehow got bent, and they don't know if it's because of something that it hit or it can't go any farther, and they're trying to
I
figure out
thought they
how
were
to fix
afraid
it.
that if they took it out, they wouldn't be able to get it back.
Yeah,
down
and that's
there.
exactly, and that's why it's going to take a while, because in addition to trying to figure out on Earth different options, the engineers are going to be spending the next couple of weeks playing around with the simulators we have here to see if it's possible. Then they have to send these commands to Mars, and it's going to go very slowly. So unfortunately, one of the big experiments that they were hoping to get working, at the moment they can't get the probe in, so they're trying to figure out ways to either readjust the probe back to make it go straight again, or to pull it back out and have a restart. They don't know if it's going to work, and that's...
Yeah, I saw the photograph of them. It looked like they recreated that probe in a lab somewhere.
Yes.
With a Mars-like surface.
Yeah, any of these probes that we sent to Mars, they have 2 or 3 analogs here on Earth. And the whole point of those analogs on Earth is to do exactly this. So that if problems happen, they can test it, they can move it around, they can adjust it, and see if this is something that will fix the problem on the model that's on Earth. And then if it seems to work, then they can try it on Mars. You don't want to try it on Mars and find out you really screwed something up. You'd rather screw something up here where you can fix it and then reset everything and try it again.
Oops, there goes $1 billion.
Yeah, I mean, for example, like the Curiosity rover, which is the current rover, that's the van-sized rover that's on Mars. They've got a Curiosity rover in the United States at a test facility. So whenever it runs into a problem, they put that rover on Earth in an exact situation, and they try different ways of dealing with that problem until they figure out this is the best way, and then they send that message to the rover to try and get that resolved.
Isn't that how they managed to talk to Matt Damon when he was on Mars? They had
You almost made it, Alex.
But that's what you reminded me of.
Almost made it. You came so close. You got to the goal line and didn't punch it through.
But that was the theory.
So Matt Damon was actually using the either Opportunity or Spirit, one of those rovers, not the. I mean, that's a little.
no,
myth
but that
about,
was the theory. That was the way the movie was able to make it plausible. Was that
he grabbed the rover and he brought it in and powered it up, and so that he could
that
use that.
wouldn't have worked if they didn't have. My whole point is that they had a mock-up down on Earth that they were able to.
Right. And so when they figured out what he was trying to do, they grabbed that mock-up
Mock-up.
and started figuring out different ways to work with it.
So NASA does that all the time when they
Yes.
do these kind of
Yes.
deep space.
Again, whenever they have one of these kind of probes, they usually have 1 to 3 simulators of exactly the same probe or the same robot or whatever, so that if it runs into a problem, they can test different things out with people standing around it. And then when they figured something out, they send a message.
Yeah. I'm sorry. That's what hit. It was. So it's modern entertainment mimicking true science.
Well, I gotta say that is one of the things about that movie, the whole fact that you've got teams of engineers on Earth trying to figure out problems. It isn't just one person, doing everything like you'd see in, bad movies.
Matt, you're screwed. Good luck.
Yeah. I mean, as a side issue, if you ever get a chance, the Apollo 11 documentary that just came out a few weeks ago, I do recommend people watch it. Watching all the teams around the astronauts, from the engineers at Mission Control to the engineers at the Johnson Space Center in Florida, the guys who are, suiting them up. It's fun watching. There's this one guy that's just standing next to the 3 astronauts as they're walking out of the building into the van to carry him. There's a guy standing there in a fire suit and his fire extinguisher in case those guys catch fire. That is the air conditioners. And if something catches fire while they're walking around, the guy's there with the fire extinguisher to put them out.
That's reassuring, I'm sure.
Yeah.
All right, we're gonna wrap it up here, Bobby.
Mm-hmm.
All right. So if you have any questions about these stories or anything else science related, you can call Alex right now at 203
837
99.
2-4.